Assalamualaikum. Alright, in this video we are going to discuss on the derivatives of logarithmic and exponential functions. Alright, so if we have let's say we have these exponential functions. If we want to differentiate this, so this is actually dy over dx, so we differentiate, we will get what we call ex. Ex is differentiated to be ex, meaning that it is unchanged. Right, so if you have ln x, if you differentiate ln x, so dy over dx will give you 1 over x. All right, so remember, for e to the power of x will give you e to the power of x after derivative, but for ln x it will become 1 over x. All right, so let's look at the first question. Right, so what if you are given e to the power of 2x? Since it is from the rule that we have memorized here, all right, so we have to write that it is unchanged. If you are given e to the power of 2x, so dy over dx will become e to the power of 2x. But all right, we are going to differentiate the 2x here. All right, so that 2x will be differentiated, so you differentiate 2x will become 2. All right, so now you have to simplify this one. You will get 2e to the power of 2x. Okay, all right, so let's look at the second question. Right, so the first one, all right, okay, the second question, you're given with e to the power of sine x. Right, so we know that for e, which is exponential function, it is unchanged, so you just copy this, the same thing. All right, e to the power of sine x, but now it is not x at the power, so it is sine x, so you have to differentiate that sine x, so that will become, all right, differentiate sine x will become cos of x. All right, so your final answer can be written as, okay, you can write e to the power of sine x cos x. Right, same thing. All right, okay, so let's look at the third question, the example. Right, so firstly, we know that from the rule, for the exponential, it is unchanged, so you just copy, so e to the power of negative 6x squared. But now you have to, what do we call that, differentiate the power, so you will get, all right, differentiating that, it will give you, all right, you bring down and then copy, so negative 12 of x. Okay, so that negative 12 of x is usually written in front here, so it's something like negative 12x e to the power of negative 6x squared. Okay, something like this. All right, so let's move to the question number 4. We have this, so firstly, all right, that 2 is a constant, so you just copy the 2, and then you have to differentiate this e, so you will just copy the whole thing, e to the power of tangent 3 of x. Okay, but now it is tangent 3x, it is not x, so since it is tangent 3x, you have to differentiate tangent 3x. So differentiating tangent will become secant square of 3x, but now it is 3x. All right, so we denote that if it is 3x here, so you have to differentiate that 3x, so differentiating 3x will give you 3. So you have to simplify this, so please take note that these 2 and 3 can be multiplied together, so you will become, all right, so be simplified as, 2 multiplied by 3 you give you 6, so 6 e to the power of tangent, all right, 3x, then you have secant square of 3x. That's your final answer. Okay, so let's move to question number 5. You have negative 3 e to the power of cos x squared. All right, so what you have to do first is to differentiate the exponential, so we'll give you the same thing, negative 3 cos of x squared, but now you have to differentiate, what do we call that, the cosine function. So differentiating that cosine function will give you negative sine, so negative sine of what, sine of this x squared, so negative sine of x squared. But since it is x squared, so you still have to differentiate that x squared, so that will give you, all right, differentiate this x squared will give you 2x. Okay, something like this. So you have to simplify this. So negative with negative will become positive. So it will give you, all right, 3 multiplied by 2, you give you 6. 6, we put x first, so 6x e to the power of cos x squared, and then we have sine of x squared. Okay, something like this. All right, so we have done 5 questions for exponential. Okay, let's look at the next example. All right, what if we have something like this? So bear in mind that if you have 2 terms here, so this is considered as u and this is considered as v, so you have to you have to use the product rule. But in this case, you can still modify it to be simplified as, you know, e to the power of, since the base is the same, which is exponential, so you can add together the what we call the power. So x squared, the index, all right, x squared plus sine x. All right, so this is using the rule for index, where a to the power of m multiplied by a to the power of n, so this will give you a to the power of m plus n. All right, something like this. And then only you differentiate. Right, so to differentiate, you refer to this one. Okay, so differentiating that, so give you the same thing, e to the power of x squared plus sine x. So the next thing that you have to do is to differentiate the one at the index. So this, the whole thing here. So put in a bracket. So differentiating x squared will give you 2x. Differentiating sine x, so plus that. Differentiating sine x will give you cos x. Okay, so you'll have something like this. So you may write, all right, so that 2x, please put in the bracket, all right, 2x plus cos x, all right, and e to the power of x squared plus sine x. Okay, if you want to expand, so be careful, you have to multiply the whole thing here, all right, or something like this, but you don't have to multiply, I guess. All right, in this case, you just leave your answer like this. All right, let's look at question number 7. If you have this function, so you have to, what do we call that, modify a little bit so that you won't make silly mistakes. So e to the power of sine square x is meant as e to the power of sine x to the power of 2 outside the bracket. Okay, it is something like this. So firstly, you have to copy everything. dy over dx, differentiating e, so it will give you e to the power of sine square x. It's not changed. Right now we have to differentiate the index here. So to differentiate that, you have to use the bracket technique. So it will give you multiply by 2. All right, so you copy everything, sine of x, and then you have to 2 minus 1. All right, that is the bracket technique. But then you still have the sine of x inside the bracket to be differentiated. So you have to differentiate that sine x. So differentiating sine x will give you cos of x. All right, so you have to simplify this. So this will give you, all right, you put 2 in front. So 2e to the power of sine square of x. All right, so you have sine x cos x. All right. Okay, that looks good. All right, so we are done with exponential functions. So you have to try some other exercises for differentiating the exponential functions. So let's move to logarithmic function. So please take note that we are using this ln function here, where the base for the log is actually e. Okay, ln is actually, right, so ln is actually log base e. Okay, so now when you differentiate that ln x, it will give you 1 over x. So if you have this ln 3x, so what you have to do firstly is to put, all right, so if you have ln x, it will give you 1 over x. But now if it is ln 3x, so you put 1 over 3x there. But then you have to differentiate that, what we call 3x. So differentiating 3x will give you 3. So you can write this as, all right, so 3 over 3x. All right, you can't simplify this, so 3 and 3 can be cancelled. This is, all right, the common mistake that students make, they will write the final answer as x. No, x is at the denominator, so please take note that when we cancel, we leave at 1 there. So the final answer should be 1 over x. All right, so let's move to question number 9. We have ln secant x, all right? So firstly, we have to write the secant x, All right, so ln of that, so we put ln secant x is okay, 1 over secant x. So now we have to differentiate this secant x, all right, because we have to differentiate the one in the bracket. So differentiating secant x will give you secant x tangent x, all right. So this can be written as secant x tangent x over secant x. Do we have the same term here? Yes. The secant x with secant x can be cancelled. So you have the tangent x, your final answer. Okay. Alright, so let's move to number 10. If you have these two ln sine of x squared, quite a complicated function here, but it's okay, we can try it one by one. So you have 2 here, so you put 2 first, because 2 is not involved in that differentiation, because 2 is the constant, is the coefficient there. Right, so 2 ln of sine x squared, so you put sine x squared at the denominator. All right, what you have to do is to differentiate these sine x squared. Right, so differentiating sine x squared. All right, so firstly differentiate sine. Differentiating sine will give you cos. Cos of what? Cos of x squared. All right, because it is not x, it is x squared. You still have to differentiate that, what we call x squared. So differentiating x squared will give you 2x. All right, so now we'll leave you have to simplify. Your final answer will be 2 and 2 can be multiplied here, so it will give you 4x cos of x squared over sine of x squared. But please don't cancel this x squared with x squared, and then it will be okay, so I cancel this. All right, what do you mean by this? Because this sign cannot be alone here. Sign of what? If you write this sign, it is not sign, it is sin. Those already. Okay. All right, so please don't cancel this. All right, the angle shouldn't cancel that. All right, so nothing can be cancelled here, so you just leave your answer like this. Right. So let's move to question number 11. All right. Okay, we have this function. So firstly, we know that if we use this, let's say, all right, so x cos x, so the next thing we have to differentiate the one in the bracket, but we have the two terms u and v, so you have to use the product rule. But it is quite complicated when you involve the product rule inside your calculation for differentiation. So you try to avoid this by using the properties of logarithm, where you can rewrite this as the addition of 2 logarithms, where ln of x cos x will be written as ln of x plus ln of cos x. All right, because we have the rule saying that ln of a multiplied by b will give you ln of a plus ln of b. This is the properties of logarithm. All right, so we have to differentiate one by one here. We're going to differentiate these and also this one. Differentiating the first one will give you 1 over x, and then you have addition in the middle, and then you have to differentiate the cos x, so will give you 1 over cos x. So you have to differentiate what we call that cos x and stuff. So differentiating cos x will give you negative sine x. All right, so you can simplify this as, all right, 1 over x minus sine x over cos x. So please take note, you can simplify that sine x over cos x as 1 over x minus, since sine x over cos x is tangent x, so you can write tangent x here. All right, so that's your final answer. Okay, so let's look at question number 12. We have ln of cos to the power of 3 of 2x. All right, there are so many ways of doing this, but the one way you can do this is actually simplifying this ln first. All right, so you have this ln of cos 2x to the power of cos 3 means cos 2x to the power of 3. That's what it means by the power of 3. And using the properties of ln, you can bring this 3 in front here. So this will give you 3 ln of cos 2x, right? So this is easier for you to what do we call that, differentiate. So firstly, we're going to differentiate this ln, so 3 over the whole thing inside the bracket, so cos of what we call that 2x, and then you have to differentiate the one in the bracket, which is cos of 2x. So firstly, differentiating cos will give you negative sine of what? Negative sine of 2x, and then you have to differentiate the 2x. So differentiating 2x will give you 2. So simplifying this will give you 6 negative 6 sine of 2x over cos of 2x. And please take note that sine of 2x over cos of 2x can be simplified as tangent x. So you can write your final answer as negative 6 tangent of 2x, right? So if it is sine 2x over cos 2x, it will become tangent 2x. All right, so that's your final answer. So what about number 13? So the same goes to number 13. So you can simplify these the logarithmic expressions first. So this can be written as ln, square root means tangent x to the power of 1 over 2. You can bring this 1 over 2 in front there, so it will become 1 over 2 ln of tangent of x. Okay, something like this. So now you're going to differentiate this, so you'll have 1 over 2, I'm going to use the purple color. So 1 over 2. All right, so differentiating ln will give you multiply by 1 over tangent x. So now you're going to differentiate the one in the bracket, which is tangent x. So tangent x will give you a secant square x. Okay. So you can write this as your final answer can be simplified as, you write secant square of x over 2 tangent x. All right. So I guess you can leave your answer like this. All right. Okay. So maybe you can simplify these, but alright, try to figure out yourself. Alright, let's move to question number 14. We have ln square now. Alright, so we have to use the bracket technique where you have to modify this a little bit, where the ln square means that ln of x plus e to the power of 3x. So the whole thing, the whole thing to the power of 2. That's what it's meant by that square. So what you have to do is to differentiate the bracket technique first. So you bring this 2 in front. So this will give you 2. Alright, so we'll have ln of x plus e to the power of 3x. Okay. So now you have differentiated the bracket technique. So now you have to differentiate the whole thing inside the bracket. So meaning to say that you have to differentiate ln first. So differentiating ln, it will give you 1 over the one in the bracket is x plus e to the power of 3x. So now you have to go to the innermost bracket, which is x plus e to the power of 3x. So please put in the bracket. Differentiating x will give you 1. Differentiating e to the power of 3x plus e to the power of 3x. But you have to differentiate that 3x will give you 3. Alright. So you try to simplify this one. Okay, so we'll have something like, so you have 2 ln of x plus e to the power of 3x. Okay, and then you still have, that 1 plus 3e to the power of 3x, the whole thing over x plus e to the power of 3x. Alright, so usually we'll put this one in front here. Alright, so I'm gonna write this as 2 multiplied by 1 plus 3e to the power of 3x, and then we have ln of x plus e to the power of 3x. Alright, the whole thing over the whole thing over that x plus e to the power of 3x. So I guess we can't change anything here. Alright, we can't simplify anything, so just leave your answer like this. Alright, so let's look at question number 15. If you try to use the, what do we call that? Alright, so something like you put everything in the bracket at the denominator, and then you have to differentiate this one using the u over v technique, which is the quotient rule. But it is quite complicated if you involve the quotient rule inside your calculation. So what you have to do is to modify this. So you want to simplify this ln. When you have division of two two terms inside the ln, so this means that the ln e to the power of x plus x minus ln of x plus 1. So from this, you can easily differentiate. So you have to differentiate the first part. So this can be differentiated as, okay, 1 over the whole thing here. So this will be e to the power of x plus x. So what you have to do next is to differentiate the one inside the bracket. So you have to differentiate e to the power of x first. So differentiating that will give you e to the power of x. Differentiating x will give you 1, so plus 1. Right, so you have subtraction in the middle. Right, so the next one is to differentiate this ln of x plus 1. So it will give you 1 over x plus 1. So differentiating x, all right, so since you have differentiated the ln, so now you're going to differentiate the 1 inside the bracket. So differentiating x will give you 1, differentiating 1 will give you 0, so just write 1 there. So you can simplify this, all right, so this will give you e to the power of x plus 1 over e to the power of x plus x minus 1 over x plus 1. So leave your answer like this also, okay. All right, so basically that's how you do the differentiation for logarithmic functions. So let's now look at quite complicated examples here. All right, what if you have something like this? All right, so of course you can simplify anything here. So what you can do is actually to identify this as u and this part as v. All right, so before we directly we can't use the formula for product rule, you have to differentiate u and v itself. So firstly, we identify u as x squared and v as ln of sine x. So what you have to do next is to differentiate this. So this will give you 2x. So differentiating v will give you, all right, 1 over sine of x. So differentiating the 1 inside the bracket, this will give you cos of x. All right. So this can be written as cos of x over sine of x. And please take note that cos of x over sine of x is actually cotangent x. All right. I can write this as cotangent x. All right. So now I'm going to use the formula for dy over dx for the product rule. So dy over dx is given by the formula, what do we call that? uv prime plus vu prime. So you have to plug it into the formula. So uv prime, so u and v prime. So this will give you x squared cotangent x, and then plus v of u prime, v and u prime, multiply this, so this will give you 2x ln of sine x. So we write 2x first, okay, something like this. So you get the final answer here. All right, but before you get the final answer, you have to show one by one how you get u and how you get v, and then you show the formula for the product rule that you make use of. All right, so let's move to question number 17. Again, if you have something like this, so identify this part as u and this part as v. All right, so before we could use the what we call dy over dx here, we have to find the differentiation for u and v. So u is actually 7e to the power of x, and v is actually ln of sine x. So now u prime will become 7e to the power of x, give you 7e to the power of x, is unchanged. So v prime will give you 1 over sine of x. Differentiating sine of x will give you cos of x. Again, this will give you cotangent x. All right, so you have to plug it into the formula. So before you use the formula, write the formula first. So dy over dx is actually given by uv prime plus vu prime. So this is actually, all right, so uv prime, so u multiplied by v prime, this will give you 7e to the power of x cotangent of x, plus now we have vu prime, so you multiply these two together, so this will give you 7e to the power of x ln of sine x. And you are done. All right, so let's look at the last question here. where it is quite a unique question here, where you have the log function, and we are not given anything, any rules on the differentiation of log, but we are given on the ln. All right, ln is actually log base e. So you have to change this log into ln, meaning that you have to change the base. We know that if log means that it is base 10, so we want to change the base into base e, meaning to say that we want to use the log base e of a 7x. So this will give you log base e of 10. All right. Okay, so that we can make use of log base e mean ln of 7x over ln of 10. Okay, so now when you have this, all right, this can be simplified as 1 over ln 10 ln 7x. The part that needs to be differentiated is only this part. So now that 1 over ln 10 is a constant, which is the coefficient of that ln 7x. So you write the ln 1 over ln 10 first. Right, now you are going to differentiate this part. So differentiating ln will give you 1 over 7x, and then differentiating 7x, all right, will give you 7. That is chain rule. So now you simplify where it can be simplified, which is 7 and 7 here. So you will have your final answer as, all right, so 1 over x ln 10. All right, so this is how you do it. It's quite unique here, and you try to figure it out by changing the base of the logarithmic. All right, so that's basically what different derivatives of logarithm and also the exponential functions. So this will be, bear in mind that these two together with the trigonometric functions will be used quite a lot inside the implicit functions in the next video. So don't forget to check out my next video. So thank you for watching.